Okay, so in today's lesson, we're going to cover conditional statements. Essential questions today: what are conditional statements, and what are the different forms of conditional statements that we have to concern ourselves about? So, first off, what is a conditional statement? It's a statement with a hypothesis followed by a conclusion. All right. And hypothesis and conclusion may sound like scientific, like you would see in the science class, but here in geometry, it's a slightly different. We're looking for a particular position. And oftentimes, conditional statements are called if then statements. If then statements kind of are like cause and effect is a way that oftentimes I will discuss it or describe it. The hypothesis would be the cause, the conclusion, the then, but it's not always one causes the other. That's what we don't have to lock ourselves into. Hypothesis is the part that comes after the if, but before the then. In shorthand, it's the letter P. All right. And then the conclusion is the part that comes after then. In shorthand, it's the letter Q. So a couple types of statements are these are all conditional statements. Notice that they're not always going to be in an if-then format, or they may be switched around too as well. So we need to be flexible as we read them. Right? So statement one, if you work overtime, then you will be paid time and a half. Right? Statement two, I'll wash the car if the weather is nice. Statement three, if 2 divides evenly into x, then x is an even number. 4, I'll be a millionaire when I win Monopoly. And 5, all equal angular triangles are equilateral. So be mindful about statement 5. When you take a look at that one, you're kind of like, I don't think that's an if-then statement. But we'll talk about that a little bit more as we continue on with this lesson. So a couple different forms of conditional statements that we need to be aware about. Usually we'll give you an original statement. In shorthand, we're going to write it out as if P, then Q. And when we take a look at this statement, right, P is the hypothesis, Q is the conclusion. So when I take a look at if a student has geometry, then their teacher is Mr. Yap, here is our hypothesis. A student has geometry. Their teacher is Mr. Yap is the conclusion. But note, I do not include the if and the then. The if and then are like the borders, right? We don't count the border, but they tell us where things are. All right? So the different forms are inverse, converse, inverse, and contrapositive. What do they do to the original equation? Well, converse switches the order of the hypothesis and conclusion. So it makes a slightly different logical statement. Inverse does something what we call as negate. So that's the negation symbol. So this is read as if not P, then not Q. And contrapositive flips the negation. So that's what contrapositive looks like. So these are the different forms. How does that change the structure of the actual statement? Well, let's take a look. In each statement, the if and the then stay where they are. What changes is the location of the original's hypothesis and conclusion and whether or not it's negated. So for converse, here's what happens. We switch the position of the two. So if their teacher is Mr. Yap, then a student has geometry. Inverse, right? This is where we add knots in, right? So if there's already a knot, you still add a knot. You're always adding a knot. We're negating the statement. So in this case, if a student does not have geometry, then their teacher is not Mr. Yap. So the inverse in this case is if a student does not have geometry, then their teacher is not Mr. Yap. The contrapositive then takes the inverse and then switches the hypothesis and conclusion. So the contrapositive is if their teacher is not Mr. Yap, a student does not have geometry. All right, so these are the different forms of conditional statements. Let's take a look at an example here. Find a converse, inverse, contrapositive of the following statement, then determine the validity. So whether or not it's a true statement. If false, provide a counterexample. So we have, if it has been raining, then the sidewalks are wet. So I like to mark up my text and identify first what's the hypothesis and the conclusion. So remember, a converse switches the hypothesis and conclusion. Well, what's the validity of this statement? If the sidewalks are wet, has it been raining? That might not necessarily be true. For instance, perhaps someone was watering the lawn and got the sidewalk wet, or a sprinkler was going by and got the sidewalk wet. Those are other reasons why the sidewalk might be wet. So those are counterexamples. Now be careful here. A common trap a lot of students fall into is they'll just say, oh, the sidewalk could be wet by some other factor. But if you're not specific enough, that isn't a valid counterexample. We need a very specific moment or description that counters the statement. Inverse, remember that's where we negate our original statement. So in this case, it would be, if it has not been raining, then the sidewalks are not wet. So again, this one would be false, right? Again, if there's like a sprinkler running, that could get the sidewalk wet. Doesn't mean it has rained. And then we have a contrapositive, again, which reverses the inverse. So if the sidewalks are not wet, then it has not been raining. That's actually true. No wet sidewalks, no rain. All right, the next thing we're going to talk about are biconditional statements. Biconditional statements combine the original statement and the converse. Biconditional statements usually contain the phrase if and only if. A couple additional notes, right? If both the converse and the original statements are true, we have what's called a good biconditional statement. Good biconditional statements then can be used as definitions and vice versa. So shorthand, what does that look like? Right? We still have our P, we still have our Q, but then what happens is that if you reverse them, they're both true. So hence the reason why we have a double arrow. Let's look at this next example. Given a statement, write its converse. If the converse is also true, combine the statements into a biconditional statement. Otherwise, provide a counterexample. So, A, if a number is divisible by 2, then the number is even. When I'm taking a look at that, here's my hypothesis. Here's my conclusion. So the converse then switches it. So I'm just going to quick write that one out. All right, so if a number is even, then a number is divisible by 2. That's true. The original statement is true. So if they're both true, we need to write a biconditional statement. All right, so a biconditional statement, remember, contains the phrase if and only if, and you put that in between your hypothesis and conclusion. So remember, the hypothesis is a number is divisible by 2 if and only if the number is even. All right, so this guy right here is our biconditional statement. Next example, if x is greater than 5, then the absolute value of x is greater than 5. Let's write out its converse. If the absolute value of x is greater than 5, then x is greater than 5. Now that turns out to be false. Now we need to provide a counterexample. Well, if I satisfy that first hypothesis, or this part right here, right, let's say if x equals -6, right, then we have the absolute value of -6 is greater than 5. That checks. However, -6 is not greater than 5. So -6 as an x value would be a counterexample, and that would be false. All right, that ends today's lesson. For summary,